Hi, welcome to AHA Guru question types for JEE and NEET. Every week I take up one important question type that comes up repeatedly in JEE and NEET, and we go deeply into it to understand how to solve that question type. Today we are going to focus on how to find electric field given the electrostatic potential. You may be wondering, do these questions come up very often in JEE and NEET? Yes, quite a lot. Look at all these questions, right? JEE 2021, 22, 23, JEE 2020, 2014, NEET 2017, and many more years in NEET as well. So you can see that these questions comes up almost every year in the JEE and NEET, right? And what kind of questions are these? The electric potential at this location, x, y, z, is given as a function of x, y, z. Right? V equal to 6x minus 8xy minus 8y plus 6yz in this question. If you see here, it is just simply 3x square. If you see this one, it is 4x square plus 3y square. But you can see that they're giving you V, the potential, as a function of x, y, z. And then what are they asking? They're asking you to find the electric field at a given point. In fact, all of these questions are very similar. Okay, so once you know how to solve one of them, you can solve all of them. Except the last one, which is a little bit more tricky. Here they have given the potential as a function of R. That is not the tricky part. They have not asked for the electric field. They have asked you to find the volume charge density. So that involves both what we are going to learn here, how to find electric field from potential, and then combine it with Gauss law. So this question turns out to be very interesting. I will look at this in more detail. But all of these questions are very simple and straightforward. You just need to know how to find electric field given the potential. For this, you already know the formula. What formula? You know that if I'm given potential as a function of x, y, z, you can write that as an integral, okay, from infinity to this point, x, y, z, of E dot dr, of course with a minus sign. What is the situation here we are talking about? Basically, if I have some charge distribution, at every point it produces an electric field. Right? Every point it will produce an electric field. So if I take this point A, right, I have an electric field here. Similarly, at B, I'll have an electric field there. C, I'll have an electric field here, and so on. At every point, I'm going to have different electric fields. Now, the potential at A, V at A, basically means you're bringing a unit charge from infinity. You're bringing it to this point. You're bringing it from there to here. And when you do that, the integral E dot dr from infinity to that point with a minus sign, that gives you the potential at this point. So V, you can find it by doing an integral of the electric field over this entire path from infinity till here. How do you reverse an integral? Because if I want to find E from V, you have to basically reverse an integral. What is the reverse of an integral? Differentiation, right? So E is going to come by differentiating V. It's going to come by differentiating V. I'm not going to derive this. I'm going to just tell you the formula. So E is minus dou V by dou X. What is dou V by dou X? It is dV by dx, keeping y and z constant. So basically you're saying, don't worry about y and z, keep them constant. Differentiate V with respect to X. That will give you the X component. That's why it is I cap. Dou V by dou Y, that means differentiate V with respect to Y, keeping X and Z constant. That will give you the Y component of the electric field. And so dou V by dou Y, J cap. And similarly, dou V by dou Z, so keeping X and Y constant, you differentiate with respect to Z. That will give you the Z component. So therefore, K cap. And because I have a minus sign here, here also I'm going to get a minus sign. So this is the formula that you need to remember and use. Okay. This is just simply reversing the integral. So you're doing the integral. When you do the integral, what will you get? When you write this, what will you get? This is dx I cap, right? This one is dx I cap dy j cap plus dz k cap. And when I do the dot product, I'll get ex dx plus Ey dy plus Ez dz. And that's exactly what you're reversing here. Okay, so Ex you're finding by taking dou v by dou x. Ey you're finding by doing dou v by dou y. Ez you're finding by doing dou v by dou z. And so that gives you the electric field. Okay, where you're finding the electric field from the potential. This is a very important formula you need to remember and you need to be able to use. Now, using this is very simple. For example, I gave you V is x square plus y square plus z square. Okay, in volts, obviously units will be volts. What will be dou v by dou x? What will be dou v by dou x? This is partial derivative. So you keep y and z constant. Differentiating constant is 0. So you have to just differentiate x square. So what is x square differentiation? 2x. Similarly, dou v by dou y. Well, that means you keep x and z constant. So this differentiation, 0. Differentiating y square with respect to y, 2y. Same way, dou v by dou z. Differentiate keeping x and y constant, you're differentiating with respect to z. So z square with respect to z, that will give you 2z. And so basically if I substitute this here, I'm going to get the electric field. When you differentiate this with respect to x, you get 2x. With respect to y, you get 2y. With respect to z, you get 2z. So minus of 2x I cap plus 2y j cap plus 2z k cap. So you can find the electric field once you're given the potential very easily. So all of those JEE NEET problems are going to be super easy to solve. Okay. Sometimes you're also told that the field is radial or you're given the V as a radial function. So suppose I had a spherical distribution of charge, uniform. So that means you know that the electric field at this location, at a distance r, will be the same as the electric field at this location, except the direction is different. The magnitude will be the same. Right, like that. The potential here, the potential here, the potential here will all be the same. Okay, even here. And so we write this as a function of r. So when you're given V as a function of r, you don't have to do all of this. Because E dot dr, E is in the direction of dr. So it will be E dr will give you, right, V. The integral will give you V. So dV will be minus E dr. And so E will be minus dV by dr. E will be minus dV by dr. What will be the direction? Direction will be radially outward. So radially outward. I have not given the direction here. I am just writing minus dV by dr. You have to say radially outward. Very easy to apply. For example, V is r cube. Suppose I told you that this V is r cube. Then what will be the electric field? It will be minus d of r cube by dr. What is that? 3r square. Right? 3r square. So minus 3r square. Now that is not giving you the direction. So r cap direction. This direction is called r cap. No, this is r. This direction is r cap. So you will write that the electric field vector is minus 3r square r cap. Now this formula works for one-dimensional cases, or when the field is radial, or when you have only the electric field in the x-axis direction. Then instead of writing minus dV by dr, you will write minus dV by dx. You don't need to use the full formula in that case. You just use this formula alone. Let us now see how we can use these formulas to solve the JEE and NEET questions that we looked at earlier. Let us now look at this question that was asked in JEE in 2021. The electric potential V in a region depends on x, y, z. Basically x, y, z coordinates according to the relationship V equal to 6x minus 8xy minus 8y plus 6yz. Find the magnitude of the electric field in newtons per coulomb at this point 1, 1, 1. So basically we have been given V and we want to find the electric field E. What is the formula for that? E is minus of dou V by dou x I cap plus dou V by dou y j cap plus dou V by dou z k cap. So all I have to do now is to find dou V by dou x, dou V by dou y, dou V by dou z. So this is V. So dou V by dou x of this, which is V, 6x minus 8xy minus 8y plus 6yz. How do I do this differentiation? Remember that when we say dou V by dou x, this means y and z. Keep y and z constant. But if y and z are constant, when you differentiate, they'll give you 0. Y differentiation, 8y differentiation gives you 0. Yz is constant, differentiation gives you 0. Please don't say that here it is a constant. Minus 8y is a constant, but there is x, no? So I have to differentiate both of these. Differentiate 6x with respect to x. What is that? 6. Differentiate minus 8y, which is of course a constant, comes out of the differentiation. So basically you have to differentiate x with respect to x, which is of course 1. So this is minus 8y dx by dx. So minus 8y. Minus 8y. Okay. Now this is what I found for any value of x comma y comma z. So this will be minus ex. Why minus? This is, I've just found dou v by dou x. Ex will be minus of dou v by dou x component, right? So this will be minus ex, the x component. Okay, but let us also do dou v by dou y. Dou v by dou y, same thing, you have to differentiate it to y. Here you're going to keep x and z constant. We are differentiating with respect to y. Since you are differentiating with respect to y, x and z, you are going to keep it constant. X is constant, so this differentiation will give you 0. But this x is constant, correct, but you are differentiating with respect to y, so you have to write it. So minus 8x dou y by dou y, which is of course 1, so minus 8x. What about this one? Minus 8y with respect to y. So that's minus 8, minus 8, minus 8. Okay, this is minus 8x, that is minus 8. What about this one? 6z, z is constant. So 6z, if you think outside, dou y by dou y, well, that's going to give you 1. So 6z, so plus 6z. So far clear? So that gives me dou v by dou y, dou v by dou y. Okay, and then I also need dou v by dou z. What will it be? Well, differentiate to z with respect to z. Well, that means x and, in this case, x and y are constants. Well, if x is constant, when you differentiate 6x, overall it's a constant. 6 is constant, x is a constant. So when you differentiate, you're going to get 0. X and y are both constant, so x into y is a constant as far as z is concerned. So this will also give you 0. 8y, y is a constant. So when you differentiate with respect to z, that will give you 0. So only this is going to matter. 6y, y is a constant, 6 is a constant, 6y is a constant, take it out. So differentiate z with respect to z, which is 1. So answer is 6y. So if I combine all this, I can write what the electric field must be, right? Let me write it here. So it is going to be minus of 6 minus 8y I cap, okay, and this, which is plus minus 8x minus 8 plus 6z j cap, and then finally you have 6y k cap. So plus 6y k cap. Now this is telling me the electric field where? At x comma y comma z. I want the electric field at 1 comma 1 comma 1. For that I have to substitute x is 1, y is 1, z is 1. I can do that directly here. Or I can find these values. No. If I substitute 1 comma 1 comma 1, I can find the value. Y is 1. What is it? 6 minus 8 minus 2. Okay? And then if I substitute 1 comma 1 comma 1, this is 1, that is 1. So minus 8 plus 6. So minus 16 plus 6, which is minus 10. Minus 10, right? And here if I substitute 1 comma 1 comma 1, well, x, z, they are not there. but you anyway say that you're substituting 1, 1, 1, and then what will you get? You'll get 6. So I know each of these values. I don't need to go back to that. I can directly write the electric field vector. The electric field vector is minus of minus 2 I cap minus 10 j cap plus 6 k cap. Okay? Or if I want to take this minus out, I can write 2 I cap plus 10 j cap minus 6 k cap. This will be newtons per coulomb. Now I've got the vector form of the electric field. What is the question? Is it asking you the vector? No, it's asking you the magnitude. Since only the magnitude is asked, you basically say root of 2 square plus 10 square plus 6 square. So the electric field magnitude is root of 2 square 4, 10 square 100, 6 square 36. How much is this? 140. So it is root of 140 newtons per coulomb. So that is the answer to this question. The electric field magnitude is root of 140 newtons per coulomb. So I hope that is clear. So this is how you are going to solve a question like this. Okay. Now let me look at all the other different questions. Right? If you look at each of these, is it any different from what we just did? JEE 2022. The electric potential is given like this. Well, it's only one dimensional, only in terms of x. So only dou v by dou x will matter. Dou v by dou y, 0. Dou v by dou z, 0. So you're only going to have an I cap component. And you want to find the electric field at this point. So use the formula to find the electric field at any given point and substitute 1, 0, 3. Done. NEET 2017. If you look at this, actually it is almost the same potential formula, right? Except they've asked you what is the magnitude of the electrostatic force experienced by this charge kept at 1, 1. We can answer this very easily. How? Since at this point we know the electric field, if you remember it was root of 140, no? Newtons per coulomb, multiplied by the charge, Q times the electric field will give you the electrostatic force. You only want the magnitude. So root of 140 into 2 into 10 to the power of minus 6. That will be the answer. You can do that easily. You see that same idea can be applied to solve this problem. JEE 2023. The potential is given. Determine the electric field. Same approach. Exactly same approach. 2020. Electric potential is given. A is a constant. Find the electric field at this point. Well, in terms of A, you will write the answer. That's it. So you can easily solve this one. Same way, JEE 2014 also you can solve. All of these questions, I'm going to give this to you as homework. So try them out. Very simple. You can see that you'll get a lot of confidence solving these because they're all very similar to what we have just done. Very easy to solve. And you can see that you can solve JEE questions, NEET questions quite easily. Now, I'm going to look at one question which is slightly different because it not only involves finding the electric field from the potential, it also involves using Gauss law. That appeared in the JEE in 2023 for a charged spherical ball. So this is the charged spherical ball. It is basically a symmetrically distributed, spherically symmetrically distributed charge. The electrostatic potential inside the ball varies with R given by this formula. V equal to 2a r square plus b. You can see V is a function of R. So if I say that this radius of this part, right, this whole thing is the ball. I have taken at any given radius small r, everywhere the potential is going to be the same, 2a r square plus b. Once you go to a larger value of r, you will have a different potential. Smaller value of r, you will have a different potential. But for the same value of r, you're going to have the same potential. It's a function of r. Okay, A and B are constants. R is the distance from the center. The volume charge density inside the ball is given minus lambda A epsilon. Minus lambda A epsilon. Now, all of these are constants, right? Find the value of lambda. Epsilon is the permittivity of the medium. So basically, this entire ball, the charge density is constant. Charge density is constant, and this is the potential that we are getting. Okay, how will I find out what is lambda? Basically, I want to find the charge density. Okay, once I find the charge density is given in the form of minus lambda A epsilon, and so that is going to tell us what is lambda. Now, to find lambda, I need the charge density. But how will I find the charge density? Charge density, for example, if I want the charge density inside this, well, that will tell me the total charge, because charge density into volume will give me the total charge. But the total charge inside divided by epsilon, Gauss law, will tell us that it is the flux through this surface. For that, I need the flux. Flux is E dot ds integrated, right? So that means I need the electric field. How will I find the electric field? I have been given potential. So from potential, you can find electric field. That we know how to do. So our goal right now is to first find the electric field using minus dV by dr. Once we find the electric field, then we can use that to find the flux through this surface. And the flux through this surface is basically the charge inside by epsilon. In this case, epsilon, because it is a medium, it is not vacuum. So we can write charge inside by epsilon. And once we have that, the charge inside is related to the charge density. It's also given that it is constant density, minus lambda A epsilon, all of these are constants. So that's very easy, right? Volume into charge density. So we can solve it. So first job is to find the electric field, minus dV by dr. This is V. So if I take that, minus d by dr of 2a r square plus b. B is constant. So when you differentiate that with respect to r, it's going to give us 0. 2a into 2r. When you differentiate r square, you'll get 2r. So 4ar, right? 2a into 2r. So 4ar with a minus sign. So minus 4ar. The negative sign says that the electric field is pointing towards the center, not away, not radially away. If I wanted to convert this into a vector, all I have to do is to multiply this by r cap. And you can see, assuming A is positive, right? You can say that this is pointing opposite to the r cap direction. So r cap direction is like this. So opposite means it's pointing like that. So electric field here is going to be pointing this way. There it's going to be pointing that way. Everywhere radially towards the center. Everywhere radially towards the center like this. Right, like that. So if I wanted to find the flux, now Gauss law tells us that the flux must be charge inside, and generally we'll write epsilon naught, but because here we are talking about a medium and we are only talking about the free charges, right? We are not talking about bound charges. So we can use Q in by epsilon naught. So Q inside, instead of epsilon naught, I'm going to use epsilon. So this is what I'm going to do. But what is flux? The flux through this surface, let's call this surface S. The flux through this surface will be E dot ds integrated, right? So flux, generally you should be writing it like this. Integral E dot ds over the entire surface. In this case, it's just E into the surface area, right? Except that the surface area is, you have to take it this way. E vector is pointing in the opposite direction. We don't have to think about it because already I've taken it like this. So if I take any little tiny surface area, it is going to be pointing like this. So it will be ds r cap. So when I take ds vector and take this and do a dot r cap, that's going to be 1. So all I have to do is to say minus 4ar into this surface area. What is the surface area? 4 pi r square. So it is going to be E into 4 pi r square, where I'm taking just this minus 4ar. Okay, not the magnitude of E, I'm taking this as E. So if I do that, I'm going to get minus 4ar into 4 pi r square. 4 pi r square is the surface area. 4 pi r square is the surface area. But if I wanted the charge inside, what is the charge inside? Well, that is charge density into volume. What is volume? 4 by 3 pi r cube. Charge density into the volume. Okay, so Q inside by epsilon has to be equal to the flux. So we can just write that equation. So what is the flux? This minus 4AR 4 pi R square. Right? Must be equal to this divided by epsilon, so I can get rid of that. Minus lambda A, I'll write it, and then we will cancel. Okay, so first let us get rid of this epsilon and this epsilon. Let us get rid of the 4 pi, r square cancels with r cube. Okay, and this A gets cancelled. Minus and minus can be cancelled out. Take the 3 here. So 4 into 3, 12. So lambda is equal to 12. That's the answer to this question, right? Question is find the value of lambda. Answer is lambda is equal to 12. So what have we done? We have basically found using the potential V, we found the electric field, and using the electric field we found the flux, right? E into surface area. So that will give you the flux. Now Gauss law tells us the flux must be equal to charge inside by epsilon, and so charge inside is density into volume, right? Charge density into volume divided by epsilon, and so equating that. So this was flux and this was charge inside by epsilon, and by using Gauss law we found that lambda is equal to 12. So I hope you have understood how to solve a problem like this. Very simple. It uses the idea that we already saw. From potential, how do I find the electric field? That is important because those kinds of questions comes up almost every year. Okay, in JEE and NEET, every year you will have questions like that. So you should know how to solve that. Once you learn how to solve that, this is one step away. It is asking you to find the electric field and do something more with it. Use Gauss law along with that to find the charge density. So I hope you have understood this question and you like this kind of a slight variation. Okay, this kind of a question is quite interesting. So you should know how to solve this as well. But the fundamental idea from potential, how do you find the field? I hope you have understood that thoroughly. Okay, now of course I've taken one question type, but there are so many different types of questions from all the different chapters. Now I can't cover all of that in a video like this. I have done an entire course where all concepts, all the techniques and every question type that comes up in JEE and NEET has been explained in great detail. You can see this by getting the full year recorded courses. Basically, you take the full physics recorded course from ahaguru.com. You will be able to then get all of the video lectures that will help you understand how to solve every question of this type, right? That you will get for every concept. For every concept, you will see all the question types that comes up in JEE and NEET. And in this course, I've explained how to solve each of these types of questions. If you like this video, please hit the subscribe button below. And if you have some comments or if you have doubts in physics or math, please write it in the comment section. I will take one of your questions and make my next video. See you all in the next video soon.